Of all the spectacles mankind has viewed through a telescope, there are few lovelier than a spiral galaxy. Majestic whirlpools of stars, they rotate in a stately and predictable dance. The fact that we see many billions of them in our telescopes tells us they are both common and stable. It is perhaps surprising that it is relatively easy to understand the inner workings of these cosmic pinwheels. By combining physical principles worked out by Sir Isaac Newton in the late 17th century with the observed amount of mass in a galaxy, scientists can calculate the rates at which these galaxies rotate. Using these techniques, astronomers predict how fast stars at different distances from the center of the galaxy should move. Stars very close to the center move slowly. That's because there is very little mass between them and the center of the galaxy to pull them along. Stars a bit further away move faster, as they're being pulled by all of the stars in between them and the center. As we get really far away, the stars are predicted to move slowly again. Their great distance reduces gravity to a gentle tug, so they move leisurely in their orbits. Knowing this, scientists looked at the galaxies and measured how fast stars were moving. To their surprise, they found that while the stars closer to the center of the galaxy behaved as predicted, those further away moved far too quickly. This observation was devastating to the traditional theories of gravity and motion. If the stars were moving as fast as their measurements suggested, galaxies should have torn themselves apart. It was a crisis, and astronomers and physicists scrambled to find a mistake in their calculation. Was Newton's theory of gravity wrong? Was his theory of motion wrong? Or was it possible that astronomers had incorrectly measured the galaxy's mass? All options were investigated, and all were ruled out, except one. Today, scientists believe that the answer lies in a previously unknown kind of matter called dark matter. This dark matter can be envisioned as a cloud which surrounds most galaxies. This matter is very unusual. It is affected by gravity, but it is invisible to visible light and all other forms of electromagnetic radiation. The name dark matter originates in this form of matter's inability to emit or absorb light. Dark matter adds to the gravity of the galaxy and explains the orbital speed of stars far from the galactic center. Dark matter has not yet been directly observed, but scientists believe that it is likely to be real, mostly because the other options have been ruled out. Using dozens of approaches, astronomers and physicists continue to search for direct evidence that would prove that the dark matter hypothesis is true. This question is one of the most important physics research questions of the 21st century.